So what do we have here? Some supercapacitors. 2.7 volts at 400 farads. And these ones, I got them from China for about $7 a piece. So they're kind of... they rattle around inside of there. They've been well used, but they definitely have some power. Like, I charged this one to 2.5 volts, and it ran an LED all night. And I think it probably had enough power to run it for a lot longer. It's just that it discharged by itself. The self-discharge rate on capacitors is quite high, as we all know. Now we're going to be charging this up, and we're going to test them with the discharge feature and get the milliamp hours, just like if they were a lithium battery. Now I've already done this once with one of them, and I got about 200 milliamp hours of current. But now the issue is, I think I can actually get more capacity from them, because the battery charger, once it got down to like 0.4 volts, the battery charger wasn't really sure of what to make of it, so it kind of stopped. Well, I think if I put two in series, they would still be the same amp hour, but it would be a higher voltage, so the battery balance charger could count the capacity better, because it's meant for a higher voltage battery. So we'll charge both these to 5 volts, and I hope that we might get maybe 250 milliamp hours of capacity when we discharge it. These two capacitors are now running in series, and they're 2.7 volts each, but I'll only charge them to 2.5 volts each, because I don't want to overvolt them. Bring the voltage up to 5 volts, and now it's limited to only put in 1 amp of capacity, or 1 amp of charge current at one time. So when you hook it up, putting 1 amp into it only raises it up to 0.7 volts, which this is going to be a pretty long charging session. Let's count how long it'll take. And we're going. Oh, now it may look like I might have to balance these capacitors, because this capacitor is at 1.05 volts, while this capacitor, the one I haven't been using very much, is only at 0.4 volt. So I wouldn't want them to be out of balance and break. Although I don't know how capacitors work. Maybe whenever this one reaches 2.7 volts, it will stop carrying more voltage. But I hope it's not like a lithium-ion battery pack, where whenever you bring the voltage past 4.2 volts, it just shorts out. I don't want these to short out, because, well, supercapacitors are kind of hard to come by. Okay, so now they're all running in parallel to each other, so we'll charge them to 2.5 volts, and let's start the time. And plug it in. Well, that took 1 hour and 18 minutes. It rolled over the clock on my watch. And it settles down to about 2.5 volts, so that's awesome. Let's put these in series now, and discharge them. Now that these batteries are running in series, I will go to nickel cadmium on my iMax P6. Go to discharge. It'll discharge it down to 0.1 volts, and it'll discharge at 1 amp of current. And it'll count up the milliamp hours of capacity that it has as it counts down. Well, it stopped at 0.7 of a volt instead of 0.1 volts, and I got 277 milliamp hours of current. I'd have to say though, if you built like a jewel thief type circuit that could utilize even that small amount of voltage, you could probably get close to 300 milliamp hours of current. So let's just say these have 300 milliamp hours. And now, let's get my multimeter and cross the two terminals over and see how much the short circuit is on what's left on this. Okie dokie, so positive electrode connected to the plus, and negative electrode. Let's see how many short circuit amps it has. 2.3 amps. That's not bad. That's quite a bit of power. In conclusion, I'd say supercapacitors definitely can pull some weight in the energy storage field of electronics. I was expecting them to be a lot more like average electrolytic capacitors. This is 1/4000th the capacity of one of these. So these are actually much closer to a regular lithium battery's capacity than to an electrolytic. And I was expecting these to maybe have 50 milliamp hours of capacity, not 300. That's amazing, and it blows my mind. And so these are about 1/10 the amp hour capacity of a lithium battery, and about half the voltage. So it's about overall 1/20th the power of one of these, which isn't bad at all. I can definitely see maybe in 20 years us having even more powerful capacitors that maybe have a super small self-discharge rate that could make wonderful battery packs. Like, for instance, we could have a battery that would be able to provide thousands of amps of current, like if we needed to have a vehicle that would launch us into space. I don't know, just a random thought. We could have a sudden burst of power like that from a capacitor bank. That'd be pretty awesome. I hope you enjoyed this video, and thanks for watching. See ya!